Alright, today's class is going to be on performance charts, placards, and the HV diagram. So, quick introduction to each of them all. You have your performance charts used to determine your IGE and OGE hover ceiling with a given weight and a temperature. Then you've got your three different types of placards. You have informational placards that give important information about different parts of the helicopter, and they are put in their various locations throughout the helicopter. You have your manifold pressure placards used to determine your max continuous power and your 5-minute takeoff power. And you have your V&E placards used to determine what your V&E speed is at your given heights with your V&E speed. And then we have the HV diagram. It is a diagram that shows at what height and velocity that you will be able to do an auto rotation and still land safely. So to start, we're going to go with the pressure or the performance chart. Here is an example of a performance chart for an IGE hover and a Beta 2. On the left side here you have your pressure altitude, puts in thousands of feet. Down below you have your gross weight. In the middle of the chart you have your different temperatures as they're going across. Now, in how to use this is you take, let's say you and a buddy are gonna go up for a fishing trip up in the mountains somewhere. Let's say the pressure altitude is about 8,000 feet. Well, with all your gear included, you come up to about 1,350 pounds. And by checking the weather, you found out that the temperature is about 20 degrees Celsius. So you come over to your chart, you find where about your weight is at 1350. You scroll up until you hit your temperature of your 20 degrees. From there, you come across and you find out how high you can go. So in this case, you can do an in-ground hover at 8,500 feet. So at your spot, you'd be able to do an in-ground hover. After this, you're going to want to check out and see where your out-of-ground effect hover is, and that's the way it goes. But when it comes to using your performance chart, this is how it goes. Find your weight, your temperature at your spot, and you calculate, and then you pull across to find out how high up you are. Next, we're going to move into the placards. First, you got the informational placards, which give important information about the helicopter and concerning it and spreading all around. So, for example, you have a low G placard that is on the cyclic or somewhere very visible for your pilot to see. And then on the tips of the blades, you have a placard that says never pull down, push up on opposite blade. And another example would be by the fuel, shut off fuel valve, you have a placard that says fuel on off. So kind of straightforward to the point. And for that gasoline, it shows 100 low lead for R22s. Alright, next is we're going to go talk about the V&E speed. Your V&E speed for the R22s up to 3,000 foot density altitude is 102 knots indicated airspeed. Beyond that, your V&E speed decreases, and in order to figure out what your V&E speed is, you need to find out where your temperature is and your pressure altitude. In order to find out your temperature, well, all of your aircraft has a thermometer, so you can check it. That's simple. Your pressure altitude, you take your altimeter, you dial it back to 2,992, you read what your pressure altitude is, and return it back to its previous setting. So be sure to remember what it was, so write down what your starting value is on your altimeter. Once you have your temperature and your pressure altitude, you come over to your V&E placard. You find out what your pressure altitude is, so let's say in this case 6,000 feet, and our temperature is 20 degrees Celsius. So we're going to come across over till we hit our 2 to 20, and we're going to come down from the 20. That's going to end up hitting you at your 87. So at 6,000 foot pressure altitude and 20 degrees Celsius, your V&E speed has now dropped to 87 knots indicated airspeed. Moving forward to our next placard is your manifold pressure, or density altitude, or chart. Using the manifold pressure charts, you can determine what your max continuous manifold pressure is, and your 5-minute takeoff rating. So we're just going to start this one off with, let's say pressure altitude is going to start off at 4,000 up to 20 degrees. So we're going to come up to, from 4,000, come up to 20 degrees Celsius, and we're going to come straight across. That being our max continuous, in this case, is 24 inches. Charts will have different things where you, to find out what your max continuous is 24, and to find out what your 5-minute rating is, you add 20 or 0.9 inches. So we have our 24 inches for a continuous, and our max would be add 0.9 for a 24.9 inches for your max continuous, or your 5-minute max takeoff power. So moving on to the next one is the HV diagram. You have your height on the left, and you have your velocity, your speed, on the bottom. Which the height versus the HV diagram is found in section 511 of your POH, and this is what it looks like. You got your various heights down here. It's about 400 here and 700. These are two different values for the chart. Alright, here we have the areas that inside the shaded, or what's called inside the envelope. If you were inside this range, then you would not be able to land a auto rotation safely to the ground. Down here below starts your airspeed off as 0 and 0 feet as it goes up in increments. Over here, if you were at this is like 100 feet, or 50 feet, sorry. At traveling at speeds 50 knots or faster, at 50 feet or less, you would not have sufficient time in order to reduce the collective and to be able to do a proper flare in order to land an auto rotation safely if you happen to lose your engine power at higher speeds at low to the ground. And same goes for being up in the air. If you were at 400 feet or less at sea level pressure, then you would not be able to. If you were above it, then you'd be able to land an auto rotation safely. So let's say you're at 500 feet, 0 speed, you would be able to safely land an auto rotation if you ended up having an engine failure. This 700 mark is your density altitude of 7,000 feet. That would be the difference between this shaded region and the one above. So, coming into the conclusion for today's lesson, you have your performance charts, which are used to find your in-ground effect and out-of-ground effect hover ceilings for a given weight and temperature. You have your placards, your informational placards spread throughout the helicopter, giving you certain pertinent information for the helicopter. You have your manifold pressure gauges to find out what your manifold pressure is for required tasks. You have your V&E speed placards to find out what your V&E is, and your HV diagram to figure out where is a safe area in order to, what is safe to make auto rotation at your given height and speed. So that concludes today's lesson.